Welcome back to Autistic Coder. In today's video, we're introducing dynamic programming, a powerful technique for solving problems by breaking them into smaller, overlapping subproblems. Dynamic programming is essential for coding interviews, and mastering it will take your problem-solving skills to the next level. Let's dive into one-dimensional dynamic programming. Dynamic programming, or DP, is an optimization technique used to solve problems with overlapping subproblems and optimal substructure. It involves solving smaller subproblems once and storing their results to avoid redundant calculations. To solve a dynamic programming problem, follow these key steps. Number 1, define the subproblem. Break the problem into smaller pieces. Number 2, identify the state. Decide how to represent the problem's state, often an index or sum. Number 3, create a transition formula. This is the core of dynamic programming. A transition formula determines how to move from one state to the next by defining the relationship between subproblems. For example, in the Fibonacci problem, the state at I depends on the states at I minus 1 and I minus 2, so the formula is dp of I equals dp of I minus 1 plus dp of I minus 2. It's the blueprint for building your solution step by step. Number 4, initialize the base cases. Set up the starting point for your solution. Number 5, iterate or recurse. Solve the problem iteratively or recursively using stored results. Let's revisit the Fibonacci sequence, but this time we'll solve it using dynamic programming. Instead of using recursion, we'll store results in an array of length n plus 1 to optimize performance. Now let's solve the climbing stairs problem using dynamic programming. This problem asks, how many distinct ways can you climb n stairs if you can take 1 or 2 steps at a time? Here's how we can solve the problem recursively. If n equals 0 or n equals 1, our base cases return 1. Otherwise, we return climbing stairs of n minus 1 plus climbing stairs of n minus 2. To solve this problem using DP, we just create a DP array of length n plus 1, with each element set to 0 initially. Then we initialize our base cases where n equals 0 or 1 to 1. Then the number of ways to reach any I greater than 1 is just dp of I minus 1 plus dp of I minus 2. Dynamic programming often involves storing results in a table, but sometimes we can optimize space by using variables instead of an array. Let's revisit the Fibonacci sequence with space optimization. In this example, instead of using an array, we simply track the Fibonacci sequence numbers for I minus 1 and I minus 2. Dynamic programming is the go-to approach for problems with overlapping subproblems and optimal substructure. Here are some scenarios where DP is especially useful. Problems involving sequences like Fibonacci or climbing stairs, optimization problems such as finding the minimum or maximum cost, partitioning problems such as dividing arrays into subsets with equal sums, and counting problems like counting paths in a grid or ways to reach a target sum. While dynamic programming is powerful, it can be tricky to implement. Here are some common pitfalls to watch out for. State-based representation. Ensure your DP table represents the problem correctly. Incorrect base cases. Base cases are crucial for starting your solution. Unnecessary storage. Use space optimization techniques where possible. Lack of clarity. Make sure your transition formula is logical and clear. Thanks for watching. Dynamic programming is a fundamental tool for solving complex problems, and mastering it will take your coding skills to new heights. If you found this video helpful, please like, comment, and subscribe to my YouTube channel. Monetary donations via the channels on screen are also appreciated. Your support will help an autistic adult gain financial independence. Let's keep learning and growing together. And don't forget, we have a challenge live right now. Can you count how many nodes in a binary tree have exactly one child? Be sure to check out the challenge.